imaginary and complex numbers. There's a series of videos dealing with this. Hopefully you will view the rest of them. At any time, feel free to pause or stop the video and replay it to re-examine the material. Let's get started. Here's the idea of the imaginary unit. Now, the imaginary unit, I just want to, before we dive into this, I want you to understand that the imaginary unit is dealing with -1 underneath the radical. But the question is, how do we get -1 underneath the radical? Well, we get that when we use the quadratic formula. So I've written out an example here to show you exactly how we're going to come up with a negative underneath the radical. I've got some example here. We're going to take 2 and put it in for B. We're going to take 3 and put it in for A. And we're going to take 4 and put it in for C. So I've got that rewritten over here. The 2, the 4, the 3, and the 4. So we're not really worried about out here. What we want to work with is underneath the radical. So we will start there. We've got 4 minus 4 times 3 is 12 times 4 is 48. And that's all underneath 6. We're not really worried about that 6 down there. But what we end up with is radical -44. So here we are with exactly what we were wondering about, a negative number underneath the radical. That negative number would come out as j and then the square root of 44. Right? So that gets us started. That's the theory. Underneath the radical, when we have a negative number, we bring it out as this imaginary unit j. Sometimes some formulas will use the letter I. I and j are synonymous. I is used a lot in the electrical field. All right, let's get moving here. Here's a couple of problems that we can work with this negative number. Now we've got a negative number underneath the radical. Let me just rewrite this. We've got -1 underneath that radical times 81, right? Okay, so the -1 comes out of the radical as the imaginary unit j, and the square root of 81 is 9. So 9j or j9, we'll worry about that nomenclature in a little while. But it comes out of the radical, that -1 comes out as j. All right, let's work this one. We just carry that negative on the outside. I think really it's there to confuse us, but just carry it on the outside. And then let's rewrite this again. Now let's see. We've got the -1, okay? But we need to take out square roots. So isn't 72 36 by 2? Yeah, that's 72. Okay, so what can we take out? We carry that negative outside there. Don't forget that. The -1 comes out as j, and the 36 comes out as 6, and we still have left in there square root of 2. Okay. So that's a simplification of the square root of -72. All right, this one is a little more complicated because we've got a fraction. But hopefully you've visited some of my other videos on how to work with radicals and exponents. So let's climb ahead on this one. We've got -3. We'll just carry that on the outside. And what do we have on top? -1 times 10. And on the bottom, we've got the square root of 81. Okay. The only thing we can take outside is that j, so we'll have negative 3, not a very good 3 there, negative 3j square root of 10. We have to leave that. We can't do anything with it. But down the bottom, square root of 81 is 9. Now, one little last thing, we know we can simplify this 3 and 9. So we actually have negative j square root of 10 over 3. All right, so all we're doing is we're dividing it up into negative 1 times something. And then, as previously learned with working with radicals, take to the outside whatever you can that's inside the radical. Ready to try? Here's one for you. Stop the video and try this one on your own. When you've completed it, take a look at the answers in the website. All right, let's add on to this concept. We know that negative 1 underneath the radical comes out as j, but there's a very nice thing that happens when we square that j. If we square that j, we know that it's radical 1 squared, and anything, the square root of anything squared comes out as the number that's underneath the radical. So therefore, negative 1. So j squared equals negative 1. And that's going to come in very handy when we do some more problems. When we end up with either j or j squared, we're going to know how to work with it. All right? All right, so let's give it a try. Here we have negative 7 squared. Okay, let me just step this through. What we have is the square root of 7j squared. So I took the negative 1 outside and put it as j. All right, so now what do I have? The square root of 7 squared is the number itself. So we have 7. And then we have j squared. What do we just say j squared is equal to? Negative 1, right? So we have 7 times negative 1 is negative 7. So the simplification of this equation is negative 7. All right, let's try another one. We're just going to write this down. I'm skipping a couple of steps, but hopefully we've got the hang of it. If not, go back to the other slides. Negative 16 underneath the radical. That comes out as 6j, right? We just covered that. Negative 36 comes out as, I'm sorry, I'm jumping ahead. The square root of 16 is 4, and the square root of 36 is 6. So I jumped ahead there a little bit. Sorry about that. So we've corrected it now. So what we have is 3 times 4 times 6. That should give us 72. And we add the j's. We've got 2 of them. J squared. Now what was j squared equal to? Negative 1. So our answer to the simplification of this problem is negative 72. Now that's a lot easier than what we've got here. All right, I want you to try it. Here's a problem. Pause or stop the video and try it. and then look at the website for the solution. All right, ready to get a little more complicated? Here we are with the fractions again. All right, we're going to multiply fractions. So we know that we could take this negative sign out as j, and this negative sign out as j. So let's see what we can do. If we have j times the square root of 16 over 81. Let's take that right out. We're skipping a couple steps here. So we've taken the negative out. What is the square root of 16? 4, right? And what is the square root of 81? 9. Okay. Times, we've taken the j out. So we've gotten rid of the negative sign. What is the square root of 9? 3. And the square root of 64? 8. Okay, so let's rewrite this a little bit. We've got j times j times 4 9s times 3 8s. And this is just a fraction, simplification. Again, we'll make this a 2, take this out, and make this a 3. So what do we have here? J squared is equal to -1. Now we've got to do our fractions here. Let's see, that comes out as 1 and 1. So that's 1. And 3 times 2 is 6. So our answer comes out as -1/6. All right? So the newness of this video is that we're taking the negative signs outside. And look what happens. It's very nice when we take two j's outside because they equal -1 and it comes up with an actual number. Pretty nice. All right, here's one for you. Stop the video, try it, and then look at the website for the solutions. Now the only negative sign you have is in this fraction. You do not have a negative sign in this fraction. So just bring them out. Bring out the square root of these two numbers. Then bring out the j and bring out the square root of these two numbers. So your answer is going to be a number or a fraction with j. J is not going to cancel out. All right, now we're really testing this j idea here. Okay. All right, -3. That's, I'm going to step it out a little bit. -1 times 3 and that's going to come out as 3j squared. Okay, -1 underneath the radical squared comes out as j squared. Okay, now this is the same thing, -1 squared and 5 squared. So it comes out as 5j squared. Then they throw in here this little extra j squared just to make it a little more complicated. Okay, now let's work on this one. -2 squared Square root of negative 2. You know any square roots of negative 2? We take the negative out as j, and we leave that square root of 2. Alright, so now we've got to put all this together. Let's bring out our numbers. 3 times 5, square root of 2, times, let's see, we have J2, 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 and J. That's J to the 7th. Alright, now let's go on a sidetrack here. J to the 7th is equal to J squared, J squared, J squared, and J. So that's equal to negative 1 times negative 1 times negative 1 times J. Negative 1 times negative 1 is positive 1 times negative 1 is negative 1. So what we end up with is negative J. Okay, so we're not quite done now that we know that is equal to negative J. So 3 times 5 is 15. We're going to bring out the negative J. I'll put that negative right up here. And square root of 2. Starting to try and put them in nomenclature that is familiar in the industry. So negative 15j square root of 2. That's an awful complicated equation that we've simplified down very nicely. Alright, I've got one for you. Stop, pause the video, try it, and look at the answers in the website. Alright, ready to go on? Alright. This is a monomial times a binomial. We know that we just, refresh your mind, distribute that inside. So what we have is 5j plus 4j squared. So we know that j squared equals, right, negative 1. So we've got 5j plus 4 times negative 1. So we'll rewrite this into normal nomenclature that future videos will be working with. Negative 4 plus 5j. That is the answer to this equation. Now notice that I put the numeral up front and the j in the end. That is the correct way to write a complex number. And we'll work with that a little bit further. Okay, again, here's one for you. I stuck in there 2/3, didn't I? Luckily, 2/3 goes into 6 and into 9 very easily. So I don't think you'll have much trouble. Stop or pause the video and take a look at your answer in the website. All right. I think we're nearing the end here. All right, let's see if we can just work this. We've got 7 on the outside, minus. Now, what is 48? Negative 1 times 49 times 2, right? 49 times 2 is 98. And we'll carry that 7 underneath. So what we end up with is 7 minus, and we'll take that 49 out as 7j, and what we have left is the square root of 2 and that's all over 7. Now all we have to do is simplify all these 7's, right? So we're going to come up with 1 minus j square root of 2. Right? Remember, these are two individual numbers. You cannot combine them. You cannot subtract them. A 7j is different from a 7. All right, here's one for you again. Try it. Pause the video, try it, and then check on the website for the solutions. All right, one more last concept that I'm going to leave you with. The conjugate of a complex number is the same thing except subtraction. We're going to be using these these conjugates when we get into operations, and that is a future video. So for right now, I'm going to leave you with the idea that an equation 1/2 minus 9j, the conjugate swaps the negative for a plus. All right? Hope you've enjoyed the video. Thanks for listening. Signing out.